Right, so finding a point of intersection by graphing each of the pairs of lines, and then we're going to verify using algebra. So I have two lines here, f of x equals 3x plus 1. So because it's just an x with no power, that makes it a linear, so it will be a line. And the same on the other one, g of x equals 2x plus 2. And again, because that's just got an x, that's also going to be a line. So I'm just going to very quickly use my calculator, and I'm going to get my ordered pairs for the f graph. So I'm typing mode and 3, and I'm typing in 3 alpha x plus 1. I'm going to get a start point just using my graph here. I'm going to get a start point of minus 1. Enter. I'm going to get an end point again using my graph. My end point is going to be 3, and I'm going to go up in steps of 1. So that is giving me input outputs of minus 1, minus 2, 0, 1, 1, 4, 2, 7, and 3, 10, which I don't think I'll be able to put on the graph anyway, 3, 10. Okay, so we'll do these in red because I have f of x in red. So minus 1, minus 2 is there, 0, 1 is there, 1, 4 is here, 2, 7 is here, and that's about as far as I can go. So try and put a line through them. There you are. That's the, in red, the graph of f of x. Okay, so we'll go over here and we'll do g of x. So same thing, I'm back on my calculator, mode 3. I'm typing in 2 alpha x plus 2. Same start, minus 1. Same end, 3. Still in steps of 1. And I have an input-output table of minus 1, 0, 0, 2, 1, 4, 2, 6, and again I won't be able to plot this, but 3, 8. So in green, minus 1, 0 is here, 0, 2 is here, 1, 4 is there, 2, 6 is there. Go get my line and line these up. Oh, so about there. And in green then is my G graph. Okay, so you can probably figure out as I was going through that, but the point of intersection is here, and that's x equals 1. If I go straight down here to 1, and it's y equals 4 if I go across there. So we always write that as point of intersection. You put the x bit first and the y bit second. Okay, so now let's do what we learned the other day, which is to verify that answer or check that answer using algebra. Okay, and the part of algebra that we use is called a simultaneous equation. So the word simultaneous in English, so if you were to do two tasks simultaneously, it would mean to do them at the same time, and it sort of has the same meaning in maths. We've got two equations and we're going to solve them together to get an answer. So we're using both simultaneously in order to generate an answer. Okay, so our first function was f of x equals 3x plus 1, and our second function is g of x equals 2x plus 2. So the first thing we can do is change the f of x into a y and change the g of x into a y. And now we have algebraic equations that we can work with because we removed the function notation and switched it into algebraic notation. So the first step is to rearrange so that we have letters on the left, numbers on the right. So if I take what was the F graph here, y equals 3x plus 1, I'm going to take the 3x, which at the moment has no sign, which means it's a plus. I'm going to bring it over here, so it's going to switch signs and become a minus 3x. So now on the left hand side, I have minus 3x. I have this y, which again has no sign, which means it has a plus. And then the 3x is gone because I've moved it, so all that's left is the 1. Do the same thing over here to what was the g graph, so y equals 2x plus 2. I'm going to move letters to the left, so I'm going to take my x, which at the moment is a plus 2x, bring it across, and it would become a minus 2x. So now I rewrite the equation as minus 2x. Again, that y has nothing in front of it, which means it's a plus. This is now gone because I've moved it, and I'm just left with 2. That's step 1. Step 2 is to cancel the x's. So to cancel the x's, you need to get the number in front of x to be the same but with an opposite sign. So for example, we need a 6 and a minus 6, or a 10 and a minus 10, or a 12 and a minus 12. So the numbers need to match and the signs need to be different. Okay, so I'm going to shoot here for a 6 and a minus 6. So if I multiply this top line here by minus 2, if I multiply minus 3 by minus 2, that's going to give me a plus 6 here. Alright? So that means if I've got a plus 6 here, I'm going to need a minus 6 here. So if I multiply this by 3, if you do minus 2 by 3, that's minus 6 here. So now I would have a plus 6 in this position, a minus 6 in this position, and that's what I need for cancelling. Now, you can't just multiply the x's, you have to multiply the whole line. So this entire top line by minus 2, the minus by a minus gives me a plus 6x. The plus y by the minus 2 gives me a minus 2y. And the 1 by the minus 2 gives me a minus 2. The minus 2 by the 3 gives me a minus 6x. The y by the 3 gives me a 3y. And the 2 by the 3 gives me a 6. Now, have what I wanted. So I wanted same number, I have that, and I want a different sign. This is a minus, this has no sign, and if it has no sign, it means it has a plus. So same number, different sign means they cancel. The rest you just add or subtract. So minus 2 plus 3 is 1y, and minus 2 plus, again you're missing sign, so it's a plus, 6 is 4. Now you don't have to do this, but you can divide across by 1, but dividing by 1 makes no difference. So 4 divided by 1 is still 4. So that was step 2, where I cancelled the x's, and to do that I generated, or when I did that, I generated my y. And the final step is to sub your y that you just worked out in to get x. So we always use the top equation. So the top equation is minus 3x plus y equals 1. And I'm going to take the fact that y is 4 and I'm going to throw it in here. So I have minus 3x plus 4 equals 1. Now I treat it like a regular equation where I get the letters on the left and the numbers on the right. So I'm going to take this 4 and I'm going to move it over here, and it will become a minus 4. and then it will be gone from here. So I have minus 3x equals 1 minus 4, which is minus 3. Now I want to split up the minus 3 from the x. So to split up, you have to divide. So I divide by minus 3. Minus cancels minus, 3 cancels 3. But if I divide on the left, I have to divide on the right, so I divide by minus 3. So x equals, and minus 3 divided by minus 3 is 1. So I got x equals 1 and y equals 4 as my point of intersection. And if I scroll all the way back up to my graph, my point of intersection was 1 and 4. Hope that helps.